The metallic clang of a 75 mm shell being loaded echoed through the cramped interior of the M4 Sherman tank. Sergeant James Mitchell wiped the sweat from his brow, his eyes fixed on the telescopic sight mounted before him. Outside, the Normandy hedgerows loomed like ancient fortress walls, each one potentially hiding a German anti-tank gun or a Panther tank that could turn his Sherman into a burning coffin in seconds. It was June 1944, and the American armored divisions were learning a brutal lesson, the war they had trained for in the wide-open spaces of the American Southwest bore little resemblance to the claustrophobic nightmare of the bocage. Every field was a fortress, every hedge was a death trap. And in this environment, the conventional wisdom about tank gunnery was about to be challenged in ways no one had anticipated. The technology they didn't understand. When the M4 Sherman rolled off the production lines in 1942, it carried with it a piece of technology that was years ahead of its time, the Westinghouse gyroscopic stabilizer. This wasn't some experimental gadget or a luxury feature. It was standard equipment on nearly every Sherman tank produced, with the exception of the 105mm gun variants. The Germans had nothing like it. The Soviets were still experimenting with similar systems. Even the British, when they received American tanks through Lend-Lease, often disabled or ignored the stabilizers entirely. The principle was elegant in its simplicity. A gyroscope spinning at high speed resisted any change in orientation. Connected to the 75mm gun through a hydraulic system, it could automatically compensate for the vertical movement of the tank as it rolled over rough terrain. In theory, this meant a Sherman could engage targets while on the move, something that had been impossible with previous tank designs. But theory and practice, as American tank crews would discover, were separated by a vast chasm of misunderstanding, inadequate training, and the chaos of combat. Lieutenant Colonel David Perkins, commanding a tank battalion in the 3rd Armored Division, later recalled the confusion. We received these tanks fresh from the factory, and someone mentioned this stabilizer system. The manual was about as clear as mud. Most crews figured it was just another mechanical headache waiting to break down. And break down it did. Or rather, crews thought it did. The early Westinghouse stabilizer was a complex piece of equipment. It required proper setup, regular maintenance, and most importantly, understanding how to use it. A tank crew that had trained for months on older models suddenly found themselves with this advanced system and minimal instruction on its operation. The stabilizer worked in elevation only, meaning it could compensate for the up and down motion of the tank, but not for turning movements. It was designed to be used at speeds up to 15 miles per hour on relatively even terrain. At these speeds, with the stabilizer engaged, a Sherman gunner could theoretically maintain his sight picture even as the tank bounced over rough ground. But there was a problem, a significant problem that would take months of combat and hundreds of lives to fully understand. The sight problem. Private First Class Robert Chen served as a gunner in a Sherman tank with the 4th Armored Division. His first combat experience came during the breakout from Normandy in late July 1944. He remembered the moment when everything he had been taught about tank gunnery seemed to fall apart. "We were advancing down this road," Chen recalled years later, his voice still carrying the weight of those memories. "Enemy infantry with Panzerfausts in the hedges. My commander is screaming for me to engage. I'm trying to use the telescopic sight like they taught us, but every bump in the road throws off my aim. The stabilizer is on, I can feel it working, but looking through that narrow telescope sight, I can't track anything. By the time I get lined up, we've bounced past the target." Chen's experience was not unique. Across the armored divisions fighting in France, gunners were discovering a fundamental mismatch between their equipment and their training. The telescopic sight mounted on the gun itself provided excellent magnification and precision for stationary shooting. It was perfect for the kind of long-range engagements envisioned in pre-war doctrine, but it had a critical limitation, a very narrow field of view. When a Sherman was stationary, this wasn't a problem. The gunner could take his time, precisely align his crosshairs, and engage targets at ranges out to 2,000 yards. But when the tank was moving, especially over rough terrain, that narrow field of view became a liability. The target would dance in and out of sight with every rock and rut. Tracking became nearly impossible. The irony was bitter. The Army had developed a sophisticated stabilization system to allow firing on the move, but the primary sighting system was optimized for stationary engagements. It was like building a race car and then equipping it with a telescope instead of a windshield. The periscope solution. The Sherman tank actually came equipped with two sighting systems. In addition to the direct telescopic sight, there was a periscopic sight mounted in the turret roof. This periscope was linked to the gun through a mechanical connection, meaning it moved with the gun and could be used for aiming. The early models of this periscope were problematic. The M4 periscope had no magnification at all. The sheet metal mount was flimsy, and the linkage could be knocked out of alignment easily. Many gunners dismissed it as a backup system, something to use only if the main telescope was damaged. But the periscope had one crucial advantage: a much wider field of view. Even without magnification, a gunner looking through the periscope could see a broader section of the battlefield. When the tank was moving, this wider view made it far easier to track targets. Some crews, through trial and error and desperate innovation born of survival, began to discover this. They found that when engaging targets while on the move, the periscope was actually more effective than the telescope, despite its lack of magnification. Staff Sergeant William Hayes commanded a Sherman in the 2nd Armored Division. His tank had been through 3 gunners before he figured out what was going wrong. "My first gunner, Thompson, he was by the book," Hayes remembered. "Always used the telescope sight. Good man. Gone in 2 weeks. Second gunner, same thing. Then I got Martinez, kid from New Mexico, street smart, not much formal education. One day we're taking fire moving through an orchard. Martinez is trying to return fire, and I see him stop looking through the telescope. He's using the periscope instead. I'm about to chew him out for not following procedure when I see him put 3 rounds right where they needed to go. 3 for 3. I'd never seen anything like it." Martinez had stumbled onto something important. When the stabilizer was engaged and the tank was moving, the periscope's wider field of view made target tracking dramatically easier. The gunner could keep the target in sight despite the tank's motion. Combined with the stabilizer keeping the gun roughly on target in elevation, it became possible to engage targets with a level of accuracy that had seemed impossible with the telescope sight. But this wasn't official doctrine. It wasn't in the manuals. For many crews, it felt like they were doing something wrong, like they were ignoring their proper sights and using inferior equipment. The psychological barrier was significant. The training gap. The fundamental problem lay in how tank crews were trained. In the United States, at facilities like Fort Knox and Camp Polk, crews learned to shoot from stationary positions. The emphasis was on precision, on taking careful aim through the telescopic sight, on making every shot count. This made sense from a peacetime training perspective. Ammunition was expensive. Range time was limited. It was easier and more cost-effective to teach static gunnery than to conduct realistic mobile exercises. But it meant that crews arrived in combat with a fundamental gap in their skills. They knew how to shoot when stopped. They didn't know how to shoot while moving, even though their tanks were specifically designed to do so. The stabilizer system itself was often misunderstood or distrusted. Mechanical sympathy among tankers ran deep. They knew that in combat, every system was one breakdown away from becoming dead weight. Many commanders, based on their experience with less reliable equipment, simply ordered their crews to keep the stabilizer turned off to avoid mechanical problems. Major Richard Winters, a battalion executive officer who later analyzed tank combat effectiveness, documented this systematic failure in a report written in late 1944. Investigation of tank crews reveals that fewer than 1 in 4 have received adequate instruction in the use of the stabilizer system. Of those who have, many report that their unit commanders discourage its use due to maintenance concerns. The result is that we are sending tanks into combat with sophisticated fire control systems that might as well not exist. The British, when they received Sherman tanks through Lend-Lease, took this to an extreme. British tank doctrine had traditionally emphasized firing on the move, dating back to their experience in North Africa. But British training methods focused on free-floating gun mounts and body position aiming rather than gyroscopic stabilization. When British crews got Shermans, they often found the stabilizer more confusing than helpful and simply disabled it. Even when the stabilizer was used, there was confusion about how to use it effectively. Some crews tried to use it with the telescopic sight, leading to frustration when the narrow field of view made tracking impossible. Others engaged it at too high a speed or over terrain too rough for the system to handle effectively, leading to the conclusion that it didn't work. The Bocage Crucible. The fighting in Normandy's Bocage country became an unintentional laboratory for American tank tactics. The hedgerows, those ancient earthen walls topped with dense vegetation, created a battlefield unlike anything the Army had anticipated. Visibility was measured in yards, not miles. Engagement ranges collapsed from the theoretical 1,000-plus yards down to point-blank distances where a Sherman crew might not even see the German anti-tank gun until after the first shot was fired. In this environment, mobility became survival. A stationary tank was a dead tank. German infantry, equipped with Panzerfausts and Panzerschrecks, could maneuver close through the hedgerows. Dug-in anti-tank guns had perfect fields of fire across the narrow lanes between hedges. The only defense was to keep moving, to present a constantly changing target. But conventional doctrine said you had to stop to shoot. Every time a Sherman halted to engage a target, it became vulnerable. The math was brutal and unforgiving. A moving target was exponentially harder to hit than a stationary one. Every second spent motionless was a second where a German gunner could refine his aim. Some crews adapted faster than others. Those who learned to fire on the move, who figured out the periscope stabilizer combination, found that they could engage targets without giving up the protection of mobility. The improvement in survivability was dramatic. Sergeant Hayes and his gunner, Martinez, became something of a legend in their battalion. Their tank, nicknamed Rolling Thunder, survived engagements that destroyed other Shermans. Word spread about their tactics, gunner to gunner, in the informal network that exists in every combat unit. Other crews started asking Martinez how he did it, Hayes recalled. At first, he couldn't really explain it. It was all instinct, you know? But we worked it out. Keep the stabilizer on. Use the periscope, not the telescope. Speed between 5 and 10 miles per hour if possible. Don't try for perfect accuracy. Just keep the rounds in the general area. The enemy can't return fire accurately if they're being hit consistently, even if you're not landing killing shots every time. The numbers begin to shift. By September 1944, as the Allied armies pursued the retreating Germans across France, some patterns were beginning to emerge in the after-action reports. Tanks that employed mobile firing tactics, using the stabilizer and periscope combination, were showing significantly lower loss rates than those that stuck to conventional stop-and-shoot methods. The exact statistics were difficult to pin down in the chaos of a fluid campaign, but battalion-level analyses suggested that crews using these techniques were not only surviving longer, but also achieving better target engagement rates. Some reports indicated improvements of up to 50% in the number of targets successfully engaged per encounter. Part of this was simply a matter of volume of fire. A tank that could fire while moving could get more rounds downrange in the same period than one that had to stop, aim, fire, then move again. In the close-range combats typical of European fighting, this mattered more than pinpoint accuracy. Staff Sergeant Chen, the gunner who had struggled in his first engagements, had by this time become one of the converts to the new methods. His account of an engagement near the German border in October 1944 illustrates the effectiveness of the technique. We came around a corner, and there's a German anti-tank gun position, maybe 200 yards away. Old me would have told the driver to stop, tried to get a perfect shot through the telescope sight. By the time we stopped, they'd have put a round through us. Instead, we kept moving. I stayed on the periscope, and I started putting 75mm rounds into their position. First shot was probably 5 yards to the left. Second shot, a yard to the right. By the third shot, I was on target. They never got a shot off. 3 of their crew down, the rest running. We kept moving, never stopped. This was the crucial insight. In many combat situations, rapid approximate fire was more effective than slow, precise fire. The stabilizer and periscope didn't make Sherman gunners better shots in the traditional sense. They made them faster shots, more aggressive shots, and most importantly, survivable shots. The officers' resistance. Despite the mounting evidence from the battlefield, official doctrine was slow to change. There were several reasons for this institutional resistance. First, there was the simple matter of tradition and training. The Army had invested enormous resources in developing a doctrine of precision gunnery. Admitting that this doctrine was flawed for mobile warfare would mean acknowledging that the training pipeline had been teaching the wrong methods. Institutional pride is a powerful force. Second, there were legitimate concerns about ammunition expenditure. Firing on the move meant lower first-round hit probability, which meant more rounds fired per target destroyed. In a mobile campaign where supply lines were stretched thin, this was not a trivial concern. Ammunition trucks had to be diverted from other uses, fuel consumption increased, and the logistics system was strained. Third, and perhaps most significant, there was a generational divide. Many of the senior officers who set doctrine had learned their trade in a different era. They had trained on tanks that couldn't fire on the move. The idea that ignoring the precision telescopic sight in favor of a simple periscope represented an improvement seemed counterintuitive, even backwards. Colonel James Hartman, a regimental commander in the 7th Armored Division, typified this resistance. In a memo to his battalion commanders in November 1944, he wrote, "Reports have reached this headquarters that certain crews are engaging targets while in motion, contrary to established doctrine. This practice is to cease immediately. Tanks will halt before firing their main armament. Gunners will use the primary telescopic sight for all engagements. The stabilizer system is an aid for quick target acquisition after halting, not a license for wild shooting while driving." But Hartman's memo came too late. The cat was out of the bag. Crews who had survived using mobile firing tactics weren't going to go back to methods that had gotten their friends burned up. Junior officers, the lieutenants and captains who actually led tanks into combat, increasingly supported their men's use of whatever tactics kept them alive. The tension between official doctrine and combat reality created a strange situation. In training areas and during inspections, crews demonstrated proper technique, stationary firing, use of telescopic sights, careful range estimation. In combat, they did what worked: mobile firing, periscope aiming, rapid fire. This bifurcation between official and actual practice was common in World War II. The Army was large enough and bureaucratic enough that it often took months or years for lessons learned in combat to filter back through the system and result in changes to official doctrine. The mechanical reality understanding why the periscope stabilizer combination worked requires understanding some technical details about the Sherman's fire control system. The telescopic sight was rigidly mounted to the gun. This meant that it moved with the gun in both elevation and traverse. When the stabilizer was active, it was constantly making small adjustments to the gun's elevation to compensate for the tank's motion. The telescopic sight, being fixed to the gun, moved with these adjustments. For a gunner trying to use the telescopic sight, this created a disorienting experience. The narrow field of view meant that small movements of the gun resulted in large apparent movements of the target in the sight picture. The constant adjustments made by the stabilizer while keeping the gun roughly on target made smooth tracking nearly impossible through the telescope. The periscope, in contrast, was mounted separately in the turret roof. It was connected to the gun through a linkage, but this connection had some play in it. The periscope's wider field of view meant that the small movements caused by the stabilizer didn't throw the target completely out of sight. A gunner could keep the target visible and tracked even as the stabilizer made its corrections. The system worked best at what engineers would call its design point, speeds of 5 to 15 miles per hour over relatively even terrain, engaging targets at ranges of 300 to 1,200 yards. At these speeds and ranges, the stabilizer could compensate for most of the vertical motion, and the periscope provided enough field of view to track the target effectively. Outside these parameters, effectiveness dropped off. At very close range, under 100 yards, the wide field of view of the periscope made precise aiming difficult. At very long range, over 1,500 yards, the lack of magnification in the early periscopes meant targets became hard to identify and engage. At high speeds, over 20 miles per hour, the stabilizer couldn't keep up with the motion, but within its design envelope, the system was remarkably effective. And crucially, this envelope covered the majority of combat engagements in the European theater. Most tank versus target engagements in France, Belgium, and Germany occurred at ranges between 200 and 800 yards, well within the system's capabilities. The technical evolution. As word of the mobile firing techniques spread, the Army's Ordnance Department began to pay attention. Engineers at the Aberdeen Proving Ground in Maryland started conducting tests to quantify the effectiveness of different firing methods. The results were illuminating. In controlled tests, comparing stationary firing with telescopic sights to mobile firing with periscope and stabilizer, they found that mobile firing at 10 miles per hour could achieve hit rates of 60 to 70% of stationary firing rates, far better than the 1/20th or 1/4 rates typical of firing on the move without stabilization. More importantly, when time on target was factored in, the mobile method often came out ahead. A tank using mobile firing could engage a target and move past it in 10 to 15 seconds. A tank using stop-shoot-move tactics might take 30 to 45 seconds to engage the same target. Even with the lower per-shot hit probability, the mobile method often resulted in target destruction in less time. The Army also began improving the periscopic sights themselves. The later M10 periscope, which started appearing on Sherman tanks in late 1944, incorporated two optical systems, a 1-power wide-angle view for target acquisition and tracking, and a 6-power telescopic view for precision aiming. This gave gunners the best of both worlds: wide field of view when needed, magnification when available. The M10 periscope also featured a more robust mounting system and better linkage to the gun, addressing some of the reliability concerns that had plagued earlier models. Crews who received tanks with the M10 periscope reported much higher confidence in the system, but these improvements came late in the war. The vast majority of Sherman tanks in service through 1944 and into early 1945 were equipped with the earlier, simpler periscopes. The techniques crews developed had to work with the equipment they had, not the equipment they wished they had. The infantry connection. The benefits of mobile firing extended beyond just tank versus tank combat. In the combined arms warfare typical of the European campaign, tanks operated in close cooperation with infantry. The ability of Shermans to provide suppressive fire while on the move proved invaluable in this role. Captain Robert Morrison, commanding a tank company supporting the 29th Infantry Division during the Siegfried Line fighting in late 1944, described the tactical implications. When we're supporting an infantry advance, the old method was to find a good position, dig in, and provide overwatch while the infantry moved. But the Germans had figured this out. Their anti-tank guns would target our stationary positions. We'd spend more time surviving than supporting. We know 'em. Once our crews learned to fire on the move, it changed the game. We could advance alongside the infantry, putting fire on enemy positions constantly. The Germans couldn't get a fix on us because we were always moving. and our infantry loved it. They felt like they had mobile artillery support right there with them. This synergy between mobile armor and infantry became increasingly important as the campaign progressed into Germany itself. The fighting became more urban, more close quarters. Static positions were death traps. The ability to keep moving while still bringing fire to bear was often the difference between success and disaster. The technique also proved effective against German infantry anti-tank teams. Panzerfaust and Panzerschreck teams relied on getting close and achieving a surprise first shot. A Sherman that stopped to engage targets gave these teams time to set up ambushes. A Sherman that kept moving, constantly sweeping likely positions with machine gun and cannon fire, was a much harder target. The psychological dimension, beyond the technical and tactical aspects, there was a psychological component to mobile firing that shouldn't be overlooked. Tank combat was terrifically stressful. Crews were sealed in a metal box, unable to see most of their surroundings, constantly aware that an unseen enemy might be lining up a shot. The feeling of helplessness when stationary, of being a target, weighed heavily on tankers. Mobile firing gave crews a sense of agency. They were doing something, moving, shooting, acting, rather than reacting. This psychological benefit translated into more aggressive tactics, better morale, and ultimately, better combat performance. Sergeant Hayes noted this in his later interviews. When we started using the mobile firing technique, the whole feel of the tank changed. We weren't sitting ducks anymore. We were hunters. The crew worked better together because we all felt like we had a chance. That confidence, it's worth more than you might think. This wasn't just anecdotal. Unit histories and after-action reports from late 1944 and 1945 show that battalions which adopted mobile firing tactics tended to have higher morale indicators, lower rates of combat stress casualties, and better overall performance metrics. The flip side was that units which stuck rigidly to conventional tactics often developed a sense of fatalism. Crews expected to be knocked out eventually. This expectation could become self-fulfilling as crews became more cautious, less aggressive, giving enemies more opportunities to target them. The German response. The Germans were not unaware of American mobile firing tactics. German anti-tank gun crews and tank commanders reported encountering Shermans that fired while moving, often with disturbing effectiveness. The German response was hampered by their own technological and tactical limitations. German tanks generally lacked stabilization systems. The Panther and Tiger tanks, while superior in armor and firepower, had to stop to fire accurately. This gave them an advantage in defensive positions or at long range. But in mobile engagements, the Sherman's ability to fire on the move could offset the German qualitative superiority. Some German after-action reports from late 1944 and early 1945 express frustration with American mobile firing tactics. One report from a Panther Company commander complained that American Shermans refused to stop and fight. They continue advancing while shooting wildly. While their accuracy is poor, the volume of fire makes precise counterfire difficult. This German perception of the American fire as wild or inaccurate missed the point. The Americans weren't trying for perfect accuracy. They were trying for tactical effect, suppression, target saturation, and above all, survival, the end-of-war analysis. As the war in Europe wound down in the spring of 1945, the Army conducted extensive surveys of tank crews and compiled combat effectiveness studies. The data on mobile firing techniques was mixed but generally favorable. Crews that had mastered the periscope stabilizer combination reported higher target engagement rates and lower loss rates than crews using conventional methods. However, they also reported higher ammunition expenditure per target destroyed. The overall assessment was that mobile firing was a valuable technique for specific tactical situations, but not a universal replacement for conventional gunnery. The final Ordnance Department report on Sherman combat effectiveness, published in June 1945, included a section on firing techniques. It noted that crews employing stabilized mobile fire reported subjective improvements in combat effectiveness of approximately 50% compared to stop-shoot-move tactics in fluid combat situations. These improvements were most pronounced at engagement ranges of 300-800 yards and when operating in close support of infantry, 50%. The same figure that had been circulating informally among tank crews for months. The official study gave credence to what frontline tankers had known through hard experience. Firing on the move using techniques that would have been considered improper 6 months earlier actually worked. The post-war legacy. The lessons learned about mobile firing in World War II had a profound impact on post-war tank development. The stabilization systems in later American tanks, the M26 Pershing, the M46 Patton, and ultimately the M60, were direct descendants of the Sherman's Westinghouse stabilizer, but they were improved based on combat feedback. Post-war stabilizers were more robust, easier to maintain, and more capable. The M60, entering service in the 1960s, had full two-axis stabilization, allowing effective fire on the move in both elevation and traverse. The sighting systems were also improved, with periscopes that combined wide field of view with high magnification, giving gunners the best of both worlds. By the time the M1 Abrams entered service in the 1980s, the fire control system had evolved to the point where firing on the move was not just possible, but expected. The Abrams could engage and destroy targets while traveling at 40 miles per hour, something that would have seemed like science fiction to a Sherman crew 40 years earlier. But the fundamental principles remained the same. Stabilize the gun. Give the gunner a sight that allows target tracking despite vehicle motion, and train crews to take advantage of mobility rather than seeing it as an obstacle to accuracy. The human element. In the end, the story of American tankers learning to fire on the move is not really a story about technology. The technology, the stabilizer, the periscope, was there from the beginning. What changed was human understanding. Crews had to unlearn what they had been taught. They had to overcome institutional resistance. They had to develop new techniques through trial and error, paying for each lesson with their lives. The phrase, ignoring their sights, captures something important about this process. From the perspective of official doctrine, crews who used the periscope instead of the telescopic sight were indeed ignoring their proper sights. They were operating outside the manual, outside the approved methods. But in combat, the distinction between proper and improper mattered less than the distinction between effective and ineffective, between surviving and not surviving. The crews who figured out how to use their equipment in ways the designers hadn't anticipated, who adapted and innovated despite institutional resistance, were the ones who came home. Sergeant Hayes, interviewed decades after the war, was asked about his combat experience. His answer captured the essence of what happened in those critical months of 1944 and 1945. We had all this equipment, you see, fancy gyroscopes, complicated sights, all sorts of technology, and we were taught to use it one way. But that way didn't work, not in the kind of fighting we were doing. So we had to figure it out ourselves. Some guys never did figure it out, and they didn't make it. But the ones who did, who were willing to try something different, even if it went against the manual, they found that you could actually fight in these tanks. You could shoot while moving. You could be effective. And that made all the difference. The cost of learning. It's important not to romanticize this process. The period during which American tank crews were figuring out mobile firing techniques was extraordinarily deadly. The summer and fall of 1944 saw some of the highest tank loss rates of the war. Every lesson learned came at the cost of destroyed vehicles and crew casualties. The 3rd Armored Division, one of the units that saw continuous combat from Normandy to Germany, entered combat with 232 M4 Sherman tanks. During the European campaign, the division had 648 Shermans completely destroyed and another 700 damaged and later repaired. That's a loss rate of 580%. The division went through nearly 6 times its initial number of tanks. Behind each of those destroyed tanks was a crew, 5 men per tank. Some survived by bailing out. Many didn't. The burned, mangled wrecks that littered the roads across France and into Germany were monuments to the learning curve, to the price paid for figuring out how to fight effectively in a Sherman. And yet, the crews who survived and who mastered the mobile firing techniques felt that the price, terrible as it was worth it. The alternative, continuing to use tactics that were demonstrably ineffective, would have been even more costly. Captain Morrison reflected on this in his later years. We lost a lot of good men, a lot of good crews. Some of them died while we were still figuring things out, using the old methods that didn't work. That weighs on you. But if we hadn't learned, if we hadn't adapted, we would have lost even more. The Germans weren't going to give us a break while we sorted ourselves out. We had to learn fast, and that learning process was brutal. The broader implications, the story of American tank crews learning to fire on the move, illustrates a broader truth about military innovation. The military is inherently conservative, and for good reason. Lives depend on established procedures and doctrine. But that conservatism can become a liability when the realities of combat don't match the assumptions built into the doctrine. Innovation in combat often comes from the bottom up, from junior officers and enlisted men who are dealing with the immediate realities of the battlefield. These frontline innovators don't have the luxury of extensive testing and validation. They have to experiment in real time, under fire, with their lives on the line. The institutional challenge is to recognize and adopt these innovations before too many lives are lost to outdated doctrine. In World War II, this process was often too slow. Lessons learned in North Africa in 1942 and 1943 were not systematically incorporated into training and doctrine until 1944 or 1945. By that time, many crews had independently discovered the same lessons, or failed to discover them, and paid the price. Modern militaries have attempted to address this through better after-action reporting, more systematic lessons learned processes, and closer integration between combat units and training establishments. But the fundamental challenge remains: how to balance the need for standardization and doctrine with the need for tactical flexibility and innovation. The individual stories, beyond the statistics and the tactical analysis, the story of mobile firing techniques is ultimately about individuals. Men like Sergeant Hayes and his gunner Martinez, who figured something out through trial and error and survived to teach others. Private Chen, who struggled at first but learned and became effective. Captain Morrison, who recognized when his crews had found something valuable and supported them despite official doctrine. Each of these men had their own story, their own war. For some, the discovery of mobile firing techniques was a turning point, the moment when they transitioned from feeling like victims to feeling like effective soldiers. For others, it was just one more adaptation in a long series of adaptations required to survive. Staff Sergeant Chen, decades after the war, was asked if he remembered the specific moment when he understood how to fire on the move. He thought for a long time before answering. "It wasn't one moment," he said finally. "It was more like everything just clicked one day. I stopped thinking about the manual, stopped thinking about what I was supposed to do, and just focused on hitting the target. Used the periscope because I could see better through it. Kept the stabilizer on because it helped, even if it wasn't perfect. Just kept moving and kept shooting until the target stopped being a threat. And suddenly I realized I was still alive, that I'd been in half a dozen fights and I was still there. That maybe, just maybe, I'd figured out how to do this job." That's what it was about in the end, figuring out how to do the job and live to do it again tomorrow. Everything else, the equipment, the tactics, the official doctrine, all of that was just tools. What mattered was coming home. The final accounting. When the war ended in May 1945, the U.S. Army conducted extensive studies of tank combat effectiveness. The findings confirmed what frontline crews had discovered through hard experience. Mobile firing techniques, using the stabilizer and periscope combination, were significantly more effective than conventional stop-shoot-move tactics in the majority of combat situations. The improvement in effectiveness varied depending on the specific circumstances. In close-range combat, at distances under 400 yards, the improvement could be as high as 70 or 80%. At medium ranges, 400-800 yards, the improvement averaged around 50%. At longer ranges, the advantage diminished, and traditional precision gunnery methods remained superior. Overall, across all combat situations, crews that had mastered mobile firing showed combat effectiveness improvements of approximately 45-55% compared to crews using conventional methods. This figure included both increased target engagement rates and reduced loss rates, 50%. The number that had circulated as rumor and anecdote was in the end supported by systematic analysis. American tankers who learned to ignore their telescopic sights to fire on the move using techniques that would have been considered improper a year earlier really were hitting significantly more targets and surviving longer. Conclusion: the human factor in technology. The gyroscopic stabilizer in the M4 Sherman was a remarkable piece of engineering, but technology alone doesn't win wars. The stabilizer had been present in American tanks since 1942, yet it took until 1944 for crews to figure out how to use it effectively. And even then, many crews never learned, continuing to use outdated tactics until the end of the war. What made the difference was the willingness of individual soldiers to question doctrine, to experiment, to share what they learned. Men like Hayes and Martinez, Chen and Morrison, and thousands of others whose names never made it into the history books. They were the ones who turned a piece of interesting technology into a combat advantage. Their story is a reminder that in war, as in life, the human element remains paramount. The best equipment in the world is useless without trained operators who understand how to use it. And sometimes true understanding comes not from manuals and training courses, but from the hard-won experience of combat itself. As Sergeant Hayes put it in his final interview given when he was in his 80s, "We had good tanks, not perfect but good, better than people gave them credit for. But it took us a while to figure out how to fight in them. A lot of guys didn't live long enough to figure it out. Those of us who did, we owed it to them to remember what we learned, to make sure the next generation didn't have to learn the same lessons the hard way." The story of American tank crews learning to fire on the move is not just a footnote in the history of World War II. It's a testament to the adaptability and innovation of ordinary soldiers facing extraordinary circumstances. They took the tools they were given, figured out how to use them better than anyone had anticipated, and in doing so, helped win a war. And that achievement, that willingness to adapt, to innovate, to survive, deserves to be remembered.